We are going to solve the next question, that is question number 8 of exercise 7.1, and the question reads like this. In a right triangle ABC, right triangle at C, okay, look at here. The question itself says the triangle ABC is a right triangle, and the right angle at where? C. So question says that triangle ABC is a right triangle. Why is it a right triangle? Because it's a right angle at the angle C is 90 degree. So we already know a right angle, a triangle is a triangle whose one of the angles would be 90 degree. So likewise here the angle C of triangle ABC is 90 degree, therefore it's a right triangle. So question gives the clue. So we have noted it here. The next thing, further it says M is the midpoint of hypotenuse M. So if you consider this right triangle ABC, we know that a right triangle has got three parts. They are, the longer side would be the hypotenuse, the slopy area is a hypotenuse, the base, this portion of this right triangle can be called as base, and this upward, or the steep, the upward area, the vertical area of the vertical part of a triangle, of a right triangle, could be called as the perpendicular. So a right triangle has got three sides. They are hypotenuse, base, and perpendicular. The question says the hypotenuse of the right triangle ABC, that is AB, is M is the midpoint of hypotenuse. That means the point M is at the middle of AB. So we can understand that the point M is dividing the hypotenuse equally into two parts. So therefore we can write as BM AB is equal to BM plus AM. Why is it so? Let me explain it once more. So it's because M is the midpoint. Since it's a midpoint, it is dividing the hypotenuse equally into two parts. They are BM and AM. So the distance from B to M, the distance from A to M will be equal. Why? M is a midpoint. So we have tried to understand that. Now C is joined to M. So look at the point. C is further joined from here to M and produced to a point D. So further it is produced to a point called D, such that DM is equal to CM. So the question further says that DM is equal to CM. That means this part is equal to this part. And we have also tried to understand that BM is equal to AM. Why? Because they are equal. So let's write here BM is equal to AM. That means this portion is equal to this portion. So from the question we have located these many things, such that point D is joined to point B. Point D is further joined downward to point B. Now the question asks us to prove four things. Which are they? First of all, we will have to prove that triangle AMC as congruent to triangle BMD. Secondly, we will have to prove that angle DBC is a right triangle. We will have to prove that angle DBC is a right triangle or right angle. Then thirdly, we will have to prove triangle DBC is congruent to triangle ACB. Triangle DBC is congruent to triangle ACB. Fourthly, we will have to prove that CM, the distance from here to here is half of AB. So we will have to prove these four things. So let's try to understand how we can prove all those things. First of all, we are going to prove that triangle AMC is congruent to triangle BMD. So if you look at these two triangles, we can understand that angle DMB and AMC are vertically opposite angles. So let me repeat it. When we look at here, angle DMB and AMC are vertically opposite angles. We already know that it is a property of a triangles. The vertical opposite angles of two lines are equal. So vertically opposite angles are always equal. So let's write here angle DMB is equal to angle AMC. The reason is since vertically opposite angles are equal. So that is the reason we have mentioned it here. Now we see that looking at when we take these two triangles DMB and AMC, the corresponding parts are also equal. Look at here, DM is equal to its corresponding part CM. AM is equal to its corresponding part B. So we can write here DM is equal to CM. Why is equal? Because they are corresponding parts or sides. Now likewise BM is equal to AM. BM is equal to AM. Why are they equal? Same applies here. Now looking at here, we understand that two sides, side angle, that means two sides of this triangle and the included angle of triangle BMD is equal to their corresponding two sides and included angle of angle AMC. So let me repeat it here. We have now proved that angle DMB is equal to angle AMC. So angles are proven. Now the corresponding two sides are also now proved to be equal. So it is indicating that these two triangles are satisfying the congruence rule of side angle side congruence rule. So since these two triangles are these two triangles, which are the triangle AMC and triangle BMD are satisfying the side angle side congruence rule, we can conclude that angle, therefore triangle AMC is congruent to triangle BMD. So we have now proved the first step. Secondly, we will have to prove that angle DBC is a right angle. Now, in order to prove, let's look into this picture very carefully. Now we know that the distance from D to M is equal to C to M. So these two distances are equal. The distance from A to M and B to M are also equal. That means the distance that is made by these two lines are equal, or what we say proportional. Therefore, these two lines are parallel. You understand, right? Since the distance between these lines are equal, or what we say proportional, these two lines are parallel. We have already studied about what we say uh, ray and transverse. So a ray is a line that goes through a single point. Now, if a line goes through more than 2 points, then we can call it as what we say a transversal. So a transversal, that is the main difference between a ray and a transversal. A ray just go through, if it goes through only 1 point, we call it as a ray, and if it is happening to going through more than one or two or more points, then we can call it as what we say transversal. Now if we consider these two parallel lines, let me draw it here, parallel lines, there are what we say three transversals we can notice here. Why are they transversal? Because they are touching these two parallel lines, they are touching two what we say points, therefore they are transversal. So we can just talk about this what we say transversal D, B, C, A. Now, according to the what we say rule, the interior angles on the same side of a transversal are supplementary. So let us write here, since the interior angles on the interior angles on the same side of a transversal or supplementary. Supplementary means 180. Supplementary angle is 180 degree. So let's learn it a little more clearly. Now when we consider these two parallel lines, we see a transversal BC here, we see another transversal DC, we see another transversal BS. So for our purposes further, we are going to just talk about this transversal BC. Now as per this what we say rule of what we say triangles or anything that we talk about further in the chapter, the interior angles on the same side, see, these are the interior angles on the same side of transversal. Their sum will be the sum of interior angles on, that means angle DBC plus angle ACB. So that's what the condition says. So if when a transversal cuts two parallel lines, the interior angles, the sum of two interior angles on the same side of the transversal will be always supplementary. That means 180. So that means as per that rule, DBC plus ACB, that means the sum of these two angles DBC and ACB is going to be 180. So let's now go further from here. DBC, let's write here angle DBC, angle ACB, in the beginning itself the question says in right angle ABC, right angle letter C. So the question itself is giving the clue that angle ABC is a right angle and C is 90 degree. Therefore ACB, angle ACB is already given, it's a 90 degree, and let's put the values. Now when we move 90 to the other side, we realize that we get, so hence we have proved that therefore angle DBC is equal to 90 degree. Now we have proved that angle DBC has a right angle just like angle angle ACP. So the second condition is also proved now. Now let's move to the third, that is about triangle DBC. So we will have to prove that triangle DBC is congruent to triangle ACB. That means triangle DBC has to be proved congruent to triangle ACB. So let's see that. Now looking at the picture, we have just proved, we have understood that the angle ACB is 90 degree. ACB is equal to 90 degree, which was already given, and look at its corresponding angle. The corresponding angle DBC is also now proved to be 90 degree. So angle DBC is also now 90 degree. That means angle ACB is equal to angle DBC. It's proven. The corresponding angles are now proved to be same. Now look at here. Both these triangles are sharing a common side, that is BC. So BC is equal to CB. So BC is equal to CB. Why? That are corresponding sides. So BC, the common side, BC is a common side of both the triangle DBC and ACB. So therefore those sides are equal. Also we have understood that these two triangles are congruent. We have proved here triangle AMC is congruent to triangle BMD. That means the corresponding parts of corresponding triangles are equal. If so, we can understand that side DB is equal to AC. DB is equal to AC. Why? Corresponding parts of corresponding triangles are always equal. So looking at here, we have understood that the two sides and an angle of this triangle DAC is equal to triangle ACB. So it is satisfying a side angle side congruence rule, since triangles DBC and triangle ABC satisfy side angle side congruence rule. We can conclude that, we can say that triangle DBC is congruent to triangle ACB. So we have proved the third step as well. Now let's try to prove the fourth demand of the question, that is we'll have to now prove that CM, the distance from here to here, we will have to prove that as half of AB. Now let's look at here. AB, we have now proved that triangle DBC is congruent to triangle ABC. That means their corresponding parts are, this part is equal to its own part, this side is equal to this side. Therefore AB is also equal to DC. So we can write it as CD is equal to AB. CD is equal to AB. Now look at here. This CD can be written as CD can be also CD is equal to CM plus DM. Why? Because the distance M is a midpoint. Since it's a midpoint, the distance from D to M and C to M are equal. So therefore, CD can be written as CM plus DM. Now, instead of CD, let's replace this CM plus DM is equal to AB. Now, since the distance from here to here and here to here are equal, I can also write that we have just written here DM is equal to CM. So, instead of DM, let me write, since DM is equal to CM, CM is also equal to DM. So, I can write CD is equal to CM plus CM. Why? Because they are equal to each other. So, CM plus, instead of DM, since DM is equal to CM, AB. Now CM plus CM, we get 2CM is equal to AB. And let's take this 2 to the other side. So, CM is equal to half of AB. Hence, we have proved that the distance or CM is half of AB.